Hey, this is Mr. Hansen. I wanted to show you how to use a little bit of technology when it comes to linear regression equations. So if you log into geogebra.org, that's kind of where you need to be, and go to Geogebra Classic. This is what we're working with. In Geogebra Classic on the right side, there are the three bars. If you click on View, you'll notice there are several options there. You might have graphics on, you might have algebra on, and you probably don't have spreadsheet on. So what you need to do is turn on the spreadsheet and turn off the graphics and the algebra. So we're just looking at spreadsheet view. Okay, from here I have already inputted some data into the spreadsheet. And what I'm going to do now is I'm going to click on A and B. So I'm highlighting both of them. And then I click on that little histogram right there. And it says two variable regression analysis. That's what I'm going for. Oh, by the way, let's talk about the data for just a second. Kind of curious, this is kind of fabricated data, but I've always wondered in my mind, if you have more people lifting weight, or maybe pulling a rope with weight on the end of it or something like that, are those, as you increase the number of people, are they going to be able to lift more collectively than they would individually? So that's kind of my question here. And so here's the data. Let's take a look at what it looks like and realize this is just kind of fabricated data, so it really won't answer the question. But let's see what it looks like. Click on that two variable regression equation. Well, this is kind of interesting. So X is the number of people. It's across the X number line. 1, 2, 3, 4, 5, 6. And Y is the pounds of weight lifted. It looks like you're going up almost the same amount at a constant rate every time. So I'd say this is probably a linear equation, based on this data anyway. And there are some things you can do. You can hit linear right there, and it'll kind of give you a line. And it looks like that's pretty good because the dots are pretty close to the line. You can play with some other ones. You could say exponential, which is kind of what I was thinking it might be. As there are more people, they have this combined effect that makes them even stronger. But I don't know if that's true or not. And it looks like the exponential, the dots aren't quite as close to the curve there. So I'm going to go back to linear. And the nice thing about this is you can plug in a number right there for X. I'm going to plug in the number, let's say there's 15 people. Not 1155. Let's backspace on that. Let's just go 15. Oh, did it again. Let's just go 11 and see what happens. Okay. And you can see that you can plug in a number for the input X, 11, and that gives you an output of 2,441 pounds. So this line here is just kind of a prediction line. The equation that we get from it is a regression equation where we can make predictions. So we just plug in a number for X into that equation. If you didn't have the computer to do it, you'd have to times by 225.954, then subtract 44, and you'd get an output there. Now 11 is kind of an interesting number. It's bigger than 1 through 8. So I'm not sure how good that is to put a number so large in when it's kind of removed from the data. There might be something else going on when you get so many people. They might get in each other's way, and it might get a little bit lower, or maybe there is a combined effect and it goes a little higher. So you can't be guaranteed of this linear trend after 8. You can't be guaranteed of that. There are things that might happen. So to make the prediction at 11 is called extrapolation, and it's a little bit dangerous to do because the trend might change afterwards. To predict within the bounds of the data, it would be called interpolation, and there's no such harm in doing that. Okay, one last thought. This is the data button right here. It says sigma x. You can kind of see that right above the 6. I'm going to click on it, sigma x, and it gives you some statistics here. It gives you the mean for x, the mean for y. It gives you all the x's added up, all the y's added up. R is kind of the piece that we're really looking at, and that's the correlation coefficient. It's really close to 1, meaning that these points are really close to being on the line, and that line is really quite a good predictor. If the points were scattered all over, we'd have a correlation coefficient closer to 0. The other numbers not so interested in right now, but that's how you find the R there. Okay, I think that's all I'm going to do for right now. This is goes with the lesson 9.1. Hopefully this helps you with any technology issues that you may be having. Please use this to practice a little bit, and thank you and have a very good day. This is Mr. Hansen signing out.